Hey guys, today we're going to be looking at LeetCode question number 79, word search. In this video, we'll begin by getting a clear understanding of the problem, and then we'll take a look at how this problem can be solved using depth-first search with an animation to see a little bit more about how the algorithm works. And then finally, we'll talk about some edge cases before diving into the Python implementation. In this problem, we are presented with a grid resembling a crossword puzzle, thoughtfully organized in rows and columns where each cell holds a single letter. This grid, referred to as the board, is accompanied by a string called word. Our objective is to ascertain whether a given word can be located within our board. To approach this problem algorithmically, it's helpful to think of it as finding a path within our board, where each step along this path corresponds to a letter in our word. For our solution, we'll be developing a recursive depth-first search function. But what does this mean? In simple terms, recursive depth-first search involves exploring a problem by diving deep into it as opposed to searching broadly across all possibilities simultaneously. Think of it as navigating a maze where you follow a path as far as it goes until you reach a dead end. At that point, you backtrack and explore another path. In the context of our problem, this depth-first search function will systematically traverse the board, searching for the letters of our word. We initiate the search at a specific cell and continue recursively examining the neighboring cells. We do this until we either find a match or encounter a situation where it's impossible to form the word. This approach allows us to thoroughly search for the word while implementing backtracking when necessary, which is a crucial strategy for solving our puzzle. Let's go ahead and code this up in Python. This is a fairly efficient solution, but I'm sure, well, I know for a fact there are more efficient solutions. There are some optimizations I didn't do to make this a little more readable, a little easier to understand. So yeah, let's get started. First thing we're going to do is check the null case. So we can say if not board. Right, if there's no board, then we return false. Hopefully that makes sense. Okay, next step, we are going to be iterating through our entire array and calling depth first search. So for that, we need two for loops. First one is for I in range length of board, and for j in range length word at 0. Iterating through all of them, and then we're going to be evaluating depth first search. So we can say if dfs, if we've found the word at that index, it's going to be I and j, then we can return true. Right, and if we go through our entire array, our entire board, and we don't find the word, then we can return false. Right. Next step, the biggest step, is going to be writing our depth first search function. So for that, we can say def dfs. Right. We're going to be passing in the board. We're going to be passing in the word. We're going to be passing in our index I or index j, and then position, which is really just the index of the letter we're looking for in word. First thing we can do is say if POS is equal to the length of our word. This means that we have gone past the last letter, and it means that we have found the word. So we can return true. If this is not the case, we have to keep going, but first we should make sure that we are actually calling depth first search at a valid index. So we can say if I is less than 0, or I is greater than or equal to the length of our board, right? Or we can do the same for j. J is less than 0, or j is greater than or equal to the length of board at 0. Cool. Oh, yeah. So if we're outside of the proper indexes, if we have an invalid index, we can just return false. And yeah, our next step is going to be to evaluate our current tile. So we can say if word at position does not equal our current, so basically if the word we're looking for is not equal to our current tile, or the letter at our current tile, j, then we return false. Cool. Our next step is going to be to save the current letter, because we're going to be modifying the board, and we're going to be swapping out the current letter for a invalid character, just to make sure that we don't go over it twice. All right, so we can say temp is equal to board at I and j. Right, just save the current letter, and then we're going to change board at I and j to be equal to hashtag, because hashtag doesn't occur. Okay, now we're going to say found is equal to, and this is basically just going to be all our recursive calls. We're going to be calling it on all the neighbors. If one of them returns found, then we will return, then found will be true and we will return found. It's kind of how we're passing whether or not we found it back up through the recursion calls. So for this, we're going to say DFS, board, word, I, j, and position plus 1, or, and then, yeah, and get rid of this last or. So this is just going to be calling on I plus 1. We're going to call on I minus 1. We're going to call on j plus 1. We're going to call it on j minus 1. Then after we have done all that, after we have gone and called depth first search on all the neighbors, we will set board at I and j equal to temp. We're putting that value back in and returning found. Right? So if this is, yeah, we're returning whether or not we found depth or found the word in one of our neighbors. All of this looks right. And yeah, okay, so last thing we have to do is actually call depth first search down here, because that was just a comment. So we can say if DFS, so if, you know, one of these indexes returns the word, we'll say board, word, I, j, and 0, and we return true. Cool. Yeah. So this is the solution. It's not, again, the most efficient, but I think it's pretty easy to understand. If you have any questions or anything, let me know. I will see if it works. Of course, a syntax error. If DFS word board. Oh, forgot a comma here. Let's see. Cool. 86%. So again, not the most efficient, but fairly efficient. Yeah, if you have any questions, just leave a comment. Don't forget to like and subscribe, smash that like button, ring the bell. I don't know. Have a good night.